Hi, fourth grade. It's Miss Kovarik. I'm here with lesson 2 for science. So you should be doing this on Thursday. So happy Thursday. I hope you've all been doing great, having a good time at home, getting your assignments done, asking for help if you need it. Um, Remember, we're here for you. All of us are here. If you need help, message us, video chat us with any questions you have. Okay? So I'm on lesson 2 science. This is what you should be looking at. We're going to read So Different Yet the Same. So please follow along with me. I'm going to read the passage. I will talk about a couple things and then I'll go over your questions for today. Okay? All right. So different yet the same. You get a juice pop from the freezer. As you eat the pop, it begins to drip. What causes this physical change to take place in your frozen treat? So when we're taking something out of the freezer, it's frozen. That means it is a solid. So when we take that solid and we put it outside the freezer, it's going to make it start to melt. And we learned last week that when something melts, it's going from a solid to a liquid. So the physical change that's happening is because it's not as cold anymore. It's in a warmer environment and it's becoming, it's going to a solid to a liquid. The sticky juice dripping down your arm is caused by a change in state. A change in state is a physical change that takes place when heat energy is added or removed from the pop. So, in order to change something from liquid to solid, solid to liquid, liquid to gas, you need to either add or remove heat. So, when we took that popsicle out of the freezer, we were adding heat. We were putting it into an area that's warmer. So when we added the heat, it started to make that frozen pop melt into a liquid. When you take a juice pop out of the freezer, the pop begins to warm up. As a result, the solid juice begins to melt. Melting is a change in state from a solid to a liquid. It takes place when heat energy is added to a solid. Evaporation, remember from our weather unit, evaporation is a change in state from a liquid to a gas. It takes place when heat energy is added to a liquid. When the water in a melted juice pop evaporates, sugar, syrup, and food coloring are left behind. So, evaporation, imagine that puddle sitting outside. If there's a puddle outside and it gets heated by the sun all day long, eventually that liquid water is going to turn into a gas. And we call water, when it's a gas, it becomes water vapor. So remember, evaporation, it's turning into a vapor, it's going into the air, and it's turning into a gas. All right, next paragraph. You can make your own pops by freezing liquid juice. Freezing is a change in state from a liquid to a solid. It takes place when heat energy is removed from liquid. So if you pour juice into those little containers and you stick it in the freezer, you are taking the heat away from it. You're putting it into a freezing cold environment. You're removing that heat and making those particles go like this from a liquid. Now they're like this, nice and tight as a solid. Let's look at the caption, physical changes. Making glass and candles are examples of physical changes. To make a glass pitcher, solid glass is heated. The glass melts and becomes a thick liquid. Then the melted glass is molded or blown into shape. When the glass cools, it hardens into a solid. So that's another example of a way that we would create something from a liquid to a solid. That's how they make glass, and that's also how you make candles. You're removing that heat. You're taking it away to make it a solid. All right, next page. So here is how you make candles. To make candles, people melt, pour, and mold. All these are physical changes. We're not changing the candle into something else. It is still the same material. We're just changing its physical properties. So first, when heat is added, the solid wax melts and becomes a liquid. You may add a color dye to the liquid wax. So first thing they're doing is melting it. They're making solid wax into liquid so that they can shape it into something else. Because we know that liquids take the shape of the container that they're in. So they're pouring the liquid right here into the cup. So all this liquid here, it was in the shape of the pan. Now it's taking the shape of the cup. The liquid wax takes the shape of the mold. It releases heat energy as it cools. So now it's cooling. Here's our liquid particles. They're moving around like this. It cools, it becomes a solid. Now they're next to each other, just vibrating slightly. They're not moving a lot anymore. So remember, we have gas. They're moving all over the place. Liquid, they're moving around a little bit. Solid is pretty normal. They stay in one spot and they just vibrate against each other. When the change in state is complete, the wax forms into a solid candle. So we just turn that from a liquid to a solid by removing the heat, by taking that heat away. Okay, let's look at our questions. Number 1. In order to change the state of matter, you must remove or add heat, chemicals, color, or energy. Please look back in the text. The answer is there. 2. Ice cream is a solid. What happens to ice cream if it is removed from a freezer? Why? What physical changes take place in the ice cream? This is a 3-part question. Please make sure you're answering all 3 parts. You need to tell me what happens to it, why that happens, and what physical change happened. Which physical change took place? Number 3, look at the candle making section. The candles change from gas to liquid, liquid to solid, solid to liquid, or liquid to gas. Go back up in the text, look for the section about the candles, and tell me what state change occurred. Number 4, same type of question. When you freeze juice to make popsicles, the matter changed from gas to liquid, liquid to solid, solid to liquid, or liquid to gas. Imagine yourself doing that. Putting juice in the freezer, what did you change that from? And the 5th one, Jaden placed an ice cube on the sidewalk in the sun. In a few hours, the ice cube will be, so if you place an ice cube outside, it sits in the sun for a few hours. When you come back and get it, is it going to be colder and solid, warmer and solid, colder and liquid, or warmer and liquid? All right, that's all I've got for today. If you guys have any questions on science, on matter, on anything that we've done the past couple days, please ask either me or one of your teachers. You can chat with us on Zoom. You can message us on Dojo, or you can comment on Google Classroom, and one of the teachers will get back to you. Hope you guys have a great day. Get outside, get some fresh air, and I will see you tomorrow. Bye.